Hi and welcome to another Unity 3D tutorial. Today's tutorial is going to be on 2D flocking. And as you can see here, I've already got the project finished and working. I'm going to step through with you to show you how to create this. And we're going to have 2D sprites moving around on the screen that are flocking with each other and also towards a goal location depending on whether you have that goal turned on or off. Alright, so let's get started with a new empty Unity project. Okay, so the first thing we need is to put the scene in 2D view. So you click on this 2D button in the scene and you'll see where the game view is restricted, which is in this white area here. Let me just move this around and zoom in a bit. So you're looking at the world in the same way that I am. Let's have a look how the camera is set up. So I have a main camera in the scene and it's set to be orthographic. It has a size of 11.6, which we could actually just set to 12. Now you can play around with that size based on how much of the world you want to see. So I did initially have it at 5, but as the particles start moving around on the screen, I needed to move out so I could see what they were doing. The clipping planes for near and far are just at the default settings, and in fact everything else is just default settings. Really what it is this 12 in size and orthographic. The position of the camera is 0, 0, -10, which is also a default position for a camera. Right, so with that in place, the first thing that we're going to need is a manager to manage our group of sprites. I'll call them particles. So we'll create particles with an empty game object to begin with. We'll call this our unit manager. And each particle will actually be a single unit that has its own code driving it around on the screen. Okay, so let's create also one of our units. Now I've brought in 2 sprites. I've got this little blue purple sprite. That doesn't make sense, does it? Blue purple. It's called purple, but it's actually blue. And I've also got a green one, and they are very small. So they're 16 by 16 pixels. They only need to be very tiny. You could just bring in a colored square if you wanted to, but it's important that you set it up to be a sprite. Okay, so now we're going to drag one of these, whether you want it to be purple or green, into the hierarchy to create our first object. And you can see that it's very small right in the center of the screen, just there. As that's probably a tad too small, I'm just going to scale it in the X and Z by 2, just to make it a little bit bigger. Of course, this is our whole screen, so we won't be looking at it when it's that small. But there it is there. You can scale it however you like it. But this will work because there's going to be a lot of particles and they're going to be moving around. So you want them to be quite small anyway. Now, after you drag that sprite into the hierarchy, you'll see that it's become its own game object with a transform, and it has a sprite renderer on it. This particle is also going to need added to it a rigid body and a collider. So in the inspector, with that sprite selected, let's add physics 2D and go to rigid body 2D. With the rigid body, we don't want the particle to fall with gravity. So if you just go through the list of things in the rigid body 2D until you can find the gravity scale, just set that to 0. Now the other thing we need is a collider. So add component physics 2D and go to, we want a circle collider 2D, and there it is there. Now you might not be able to see it because of the particle being so small. If you double click on your particle in the hierarchy, you'll find that it gets this green border around the actual sprite. So that's our physics collider, which will mean that particles will collide with each other, which is what we want for the effect that we're after. Next, we'll get our unit manager working so that it automatically creates the particles that we want it to. So for that, go to the project window and go create C# script. And this script we're going to call all units. And then open that up. And we'll start with some very simple code to just create the particles randomly on the screen. So here's our code. Just make that a little bit bigger so you can see all of it. And the very first thing you need to add is an array of game objects to hold all of the individual units that are created. Units and particles, the same thing. And then we also want to give the manager the prefab for each unit so that it knows how to create them, so that it will instantiate them later on. Then we have an int where we can set the number of particles that are going to be created. In this case, it's just going to default to 10. And we're also going to set up a range. And this range is the size of the space around the unit manager where the particles will instantiate. So where they first appear. Okay, so the next thing I've got is just a draw gizmo thing so that you can actually see the range of the unit manager. And it's going to draw a wire cube around the outside of its range, so how much range it has, essentially, from the center point. And then also a sphere in the middle. Now, you don't have to include this, but it just helps you see where your unit manager actually is. And its range, which we will use later on, is the distance from the center that these units can be created randomly scattered. Okay, so in the start functions where all the units are created. So first of all, that units array, which is defined up here, is set to the number of units that we're going to create. Then we have a for loop that loops around through this array, and in each position of the array, it creates a new unit and dumps it in there. So it creates it from the prefab that we've got and puts it into there. Now the position of each unit is calculated randomly around the center of our unit manager. That means that later on you can actually have a lot of unit managers in the scene, all with their own little set of particles, units flying around. Okay, so make sure that where you position each unit is at the position of the unit manager, which is its center point, plus this range that has been randomly generated. Okay, so just save that, and we'll go back to Unity. And we're going to put that code onto the unit manager. And then select the unit manager to make sure that it worked. Okay, there it is. Now we don't have a unit prefab yet, but what I want to show you is if we just double click on our unit manager and zoom out a little bit, in the scene view, you'll now see you've got this yellow square, which is the range of the unit manager. So if we change the range, let's make it in the X, let's say it's 15 in the X, you'll see that it changes here. So the particles when they're created will be within this space here. The Z, of course, means absolutely nothing because we're in 2D, but it's just there for completeness, I guess, because we used a vector 3. Right, so with that set, we can now create our prefab. So grab this green or whatever you called your sprite with the rigid body and the collider on it, and drag and drop that into your assets to create a prefab from it. Okay, so there it is. It looks different to the sprite, and we will just make sure it is very different by calling it green prefab. Now, if you want to make any different colored versions of this later on, you just have to copy, duplicate this prefab, and then change the sprite that is sitting over here. Okay, so with our prefab made, we can delete the sprite that's in the hierarchy, then go to the unit manager and assign this green prefab to the unit prefab. All right, so now we should be able to run it, and we will get 10 green units created within this square. Yep, and there they are there. So you can see that they're confined to it I should say rectangle. It's a rectangle, it's not a square. And there's 10 of them. Now, currently they're not doing anything. So they do have a rigid body on them, but they don't have any gravity, so they're not going to fall on the screen. And unless they're actually instantiated in exactly the same space or overlapping, they're not going to start moving or fly off anywhere with the physics system. But if you created a lot of particles in there, then that possibly would happen. Okay, so that's the beginning of our code. Now we actually have to write some code to get the green prefabs, the units, actually behaving. Now, for those of you who haven't watched my other flocking videos, the 3D videos, I just want to explain how flocking works. So I'll just open up this page, which is a shameless plug for my book, Holistic 3D Game Development, which is coming out very shortly, or I should say the second edition is coming out very shortly. And this is in chapter 5, which talks about artificial intelligence. And you can pre-order that on Amazon. Anyway, back to the flocking. In flocking, there's 3 rules, and they're so simple, yet they create this amazing complex behavior. And if you haven't seen flocking or created anything in flocking before, you'll be quite amazed what you end up with by following these simple rules and programming them in. The first rule is to, when you've got a group of particles or units in this case, is that they're going to be moving. And the first rule is to move towards the average group position. So each unit looks at all of the others and it calculates the average and turns towards the average group position, which in this case is probably around about there. The second rule is to align your heading with the average heading of the group. So this time you calculate all the headings, add all the headings up and divide by how many are in the group to get the average heading, and then turn towards the average heading. And then the final rule is to avoid hitting another unit that's in your group. Now, they're the 3 rules. These rules actually are the same rules that are used for generating herds and flocks in movies that you see, such as the herd scene in The Lion King, where all those animals are moving across the savannah. They're all use this algorithm. In fact, I think it actually was created for that movie, and now it's actually a quite famous algorithm. Anyway, so that's the theory behind that, and that's what we're going to now program. Okay, so let's go back into Unity and actually put this into action. Go into the project and create another C# script, and let's call this unit. So this will be the code that we will put onto our particle prefab, and you can actually do that now. So just grab that and drag and drop it in the project onto that prefab, and then just check via the inspector that it was actually dropped in there. Okay, let's open up this and add some code. So the first thing we want to do is to get the units moving towards the center of the manager. So that will be our goal position. Now, I realize that the actual flocking algorithm doesn't have a goal position in it, but it's a simple matter of adding in a position that you want your group to move towards, and in that way you can actually control where your flock's going. If you don't have a goal position, as you will see, they will just go off wherever they want to. So you can actually use the goal position to keep bringing them back like a magnet. So here's the code for the unit, and I'll step through each line for you. First of all, we've got a link to the manager, and this is the unit manager that's sitting in the hierarchy. We're going to use this manager to get a lot of information, and most of all, currently, is that center position, which will be our goal position. So what you want to do, and you can do in fact before you even start typing this unit code, is to go back to that all units script, and in the all units script, in the start function, underneath the instantiate for each of the units, you'll need to add in this line here. And so it's saying that the units code, the manager, which we're defining up here, is going to be equal to this .game object. So it will set it up just after it's created the unit, so the unit knows who its manager is. And that will allow you to have multiple managers with different units running. All right, so back to the unit code, we then have to maintain a location value and a velocity value, which will be used in the calculation of the movement of the particle. We then have a goal position, and we also have a current force position. Now, these are zeroed here, but it's not necessary that they're zeroed really, because they're going to be calculated later on, and with the goal position it actually gets set. So yeah, you don't really need to zero those. The current force is the force that's being placed on the particle, which actually is pushing it around on the screen, and it's that force that ends up becoming the added values of all of those different flocking rules. So, turn towards your group but don't hit your group, and go towards the goal position and try to align your position so you're going in the same direction as everyone else. That all gets added together and put into that current force, which is then used to push the particle around. We're only going to set it to a very small random value. So I've just got 0.01 in here, and it's a vector 2. So I'm going to work with vector 2s here because we're not moving in the z direction. And in the next part we have the location, and we're setting up that using the position of the actual sprite. Okay, so we're using its X and Y to set that up. Now you could just type in its position each time you wanted to use it in a calculation, but it just becomes really laborious, and your code gets really long and messy if you've got long statements like this in it. Okay, the next part is a seek function, and all this does is it works out the vector towards your target location, which is the target location minus your current location, and that will give you a vector that points from where you are to where you need to be. Okay, so the function doing pretty much all of the work, or one of them, is the apply force function, which will take our current force vector a little later on, and it will add it to the rigid body of the particle, which is done in this line, as you can see here. So we're taking our force and we're making it into a 3D force, which is actually required in this add force function, and then pushing it using that force. Now I've got a debug.drawRay in here, which is going to draw a line from the current position of the particle using the force as its direction, and it will be in white. Now I've done this so that you can actually see which way the particles think that they're moving and how they're aligning all of those different velocities. Okay, so that's the apply force. Now the other function that's doing most of the work, of course, is this flock function, because it will be calculating and controlling all of those different rules that we need to add. So first of all, we're setting the location and the velocity again, which makes me think we probably really didn't need to do it up in the start function, but we've got it now. And then we're going to calculate the goal location, and the goal location is found by using the seek on the goal position. Now, goal position is set to the unit manager's position. And that's the reason, or the first reason, that we added in the unit manager, is because in update, we're setting the goal pos to be the manager's position. Now, I've got it in the update function so that you can actually move that unit manager around on the screen, and it will still update its flocking to keep following that goal position. Now, once we've got our goal position, we're then going to make the force equal the force that's returned by seek. and that force actually is equal to the vector from our current location to the target location, because that's all that this seek function is doing. And then we're going to normalize it. So by normalizing it means we're actually going to cut it down into a unit vector. So let me just really quickly show you what that means. We have a unit and we have a goal. If we take away the goal position from the unit position, then we end up with a vector that is the entire length from the unit position to the goal position. Now, if we add that as a force, it's quite a large force to push that object with. And if you want to make sure that all of your objects are moving with the same amount of force in whichever direction they're going, then you need to normalize it, which takes a vector and makes it a unit 1 length. And no matter which direction it's actually facing for any of your units, it will always have the same amount of force behind it, which will be equal to a length of 1. Okay, so that unit force is then run through this apply force function, which, remember, adds that force to the rigid body of our unit to push it around. And then inside the update function, what's going to continually happen is that the flock function is called, which does the calculation of the direction of the goal and also pushes it forward. And then we update our goal position to the manager's position if the manager has changed. If your manager is not going to change where it is, you could put this code in the start function just to make it slightly more efficient. Right, save that code and then make sure that you have attached it to your prefab so that your units will get pushed around on the screen. And then we'll press play. Let me just zoom out a little bit on the scene view. And we'll see at first the units, okay, they're green, and the debug lines, which are showing the velocity and the direction that they're traveling in. And if we click on our unit manager, we'll be able to bring up our gizmos draw code, which is our green circle in the middle. And you can see that they're all honing in on that point there and staying quite neatly around it. Now, because of the way that we've programmed it, we can also move the unit manager. So if I just do that in the inspector, grab hold of the X value and just drag it across, you'll see that they've changed their position and recalculated where they need to go to. Now, as you do that, you actually end up building up a fair bit of force in the particles themselves, which means that they're going to start slingshotting around this goal position further and further, and you will have to write in some restrictions for that. Okay, so just before I finish this part 1, I'm going to go to our unit manager and just ramp up the number of units. So let's put 100 in there. Press play. The other nice thing about using the physics system that's already in Unity is that the rule for the flocking about actually avoiding your neighbours is already in place. We don't have to program that because the physics system will do that for us. So it might look like they're trying to stay together in a clump and flock, but it's just because they're all going for the same goal location that they just accidentally stay like that. Okay, so that's the end of the first part. In the second part, we'll add in some other rules so that they will head off together and they will start sort of clumping together as well, just to create some more extra behaviours.